Am I on? Great. This stage has these great wings. Like you could just run out from the side, yell DevOps, and run off the other side and be completely done. So good afternoon. I am Mandi Walls. I am the technical community manager for the EMEA region at Chef. You can maybe tell by my accent, I'm not actually from Europe. I am from the US, but I'm based right now in London. And if at any time you'd like to tweet at me or follow me on Instagram or any of the other social media stuff, I am LNXCHK on all relevant social media. So a bit about Chef. Is people familiar with Chef? A few hands, okay. I feel like everyone should be familiar with Chef, and like we've been doing this forever, but like that's cool. So we are based in Seattle. We have offices in San Francisco, and now in Europe we have 3. We're in Berlin. We have a dev office in Berlin. We have a sales office in London, and we have another dev office in Belfast for folks working on a project called InSpec, which I'll talk about a little bit later. We have about 270 employees worldwide. We have 3 lonely dudes in Australia who don't all live in the same city, but they're down there. We've been in the business of automation for about 10 years, so working with different customers with different goals and different kinds of projects over the last decade or so. The first tool we put together is called Chef. Originally, the company was called OpsCode, and then we changed our name to Chef, and everybody's like, how do we find you on Google? And you're like, nah, good luck. So that was a tool for automating infrastructure, and we're now working on things for security and compliance with InSpec and application automation with a new project called Habitat. So we use all of these to build workflows for our customers, for people in our community. We have a lot of open source users, folks that sort of live in our space. And we mix and match these solutions with comparable solutions that aren't necessarily Chef products. So if you dig around in some of our slide decks, you'll find things like using InSpec with Ansible and other tools like that. So where we're coming from is basically every business is a software business or is becoming rapidly a software business. And one of our sort of hometown customers is Alaska Airlines. Their headquarters is not far from our headquarters in Seattle, so they're like our buddies, right? And a couple of years ago, their CIO was one of the keynote speakers at our conference, and he was basically saying, you know, we're going to be a software company with airplanes, right? They might spend millions of dollars on the capital investments to buy all these airplanes, but the improvements to their workflows and the improvements to their customer satisfaction and those sorts of activities all come out of technology, come out of software, and the improvements that they're making there. There's only so much you can do with an airplane. It's still going to be a seat that's not quite wide enough for a human being, not quite long enough for anyone taller than, you know, my mom, and there's only so much you can do with that. But for customer experience, customer satisfaction, a lot of things come out of software. So we're seeing that all over the place. We work with a lot of large multinationals, GE being one of our biggest sort of global customers, also IHG Hotels, Bank Hapoalim, Facebook, SAP, folks like that, and working on different kinds of problems with all of these folks. Some of them are looking for sort of their first dive into what it means to run in the cloud. And some of them are looking for things that are a bit more sophisticated. They're running things like infrastructure under IoT or any of their other sort of large-scale, massive-scale kinds of solutions. So we go way back with sort of DevOps and automation and this workflow building and all these things that we're doing. We've changed our blog hosting software, I think 3 or 4 times in the past 5 or 6 years, but we keep dragging this old post along with us. And it was sort of the foundational mononym for DevOps, was written by John Willis in 2010. Makes me feel old, I don't know about you. What DevOps means to me, and it was one of those first foundational pieces that was like, okay, we write dev and ops and we squish them together and it's like you put chocolate in my peanut butter kinds of things. But John kind of put out this idea that there's all these components that go into what you need to do or what you should be thinking about when you're talking about going towards DevOps or doing DevOps or looking at DevOps workflows and those kinds of things. And the original version was only CAMS, C-A-M-S, and then later on he added in L for lean. So culture, automation, lean, metrics, and sharing. And you can read the post. It's not quite as dated as you would expect, but we've definitely come a long way. And with the addition of the sort of lean components and like working in that sort of mindset where you can be constantly changing and constantly updating, switches things around just a little bit. But we at Chef are big on the A part. We're all about the automation, automation, automation. Whatever you can automate, whatever you can get into a good, fast workflow so people don't have to always remember every crazy little thing. So as we've been working with, there we go, automation, walking into a customer and saying, yeah, you know, you really want to automate, you get a couple of different responses, right? Sometimes we see this sort of nightmare scenario where people are like, well, what happens if the automation goes wrong? What happens if I'm just doing the wrong thing hundreds and hundreds, we're doing the wrong thing really, really fast. It's not what we want to be doing with these new workflows. And it sort of goes back to Mickey here with his brooms, and he wants to be faster, he wants to get things done, doesn't want to necessarily do all the work himself, and things go a little bit crazy. That's not what we want. We want nice, controlled automation that does exactly the things that we need. We also have the discussion about what happens when the robots sort of take all the jobs. And in other parts of the economy, this becomes a much more fraught discussion. What we've seen so far in IT automation is that there's never enough hands on keyboards to get all the work done. And the folks that we work with, no matter how much we automate, there's always a gigantic backlog of thousands upon thousands of person hours that's still waiting to be done. So we're not quite yet there to where the robots are going to take all of our jobs. Maybe someday, and maybe by that time I'll have retired to Tenerife or somewhere lovely, and that would be amazing, but we're not there yet. So Chef itself and the workflows that we've been building around it started as a project in 2008, and the core components are all open source. So you can go and try it out, download it, work with it, and see how it fits for your requirements. It started as part of projects that were built as a consultancy built around another product in the same space. And the focus became on scale, reliability, repeatability for this computing infrastructure layer. And 2008 was sort of those first days of people sniffing around at the cloud, and like there was more than one person in the room, had more than 100 nodes, and that sort of thing was just getting started. So there are some architectural decisions built into Chef to make workflows around working with large numbers of hosts much more easy than maybe they would be with other solutions. We've gone in on DevOps at the very beginning, like that post from John, 2010, early days of all of that sort of thing, like making sure that you're sharing all the things that you're doing, that all your workflows and all your metrics are open, that everyone can sort of see what's going on. You're sharing your infrastructure code with your dev teams so folks know what's going on and how things need to be built. Started out with support for Linux, and in the early days it was only Ubuntu, and over time I've built in more things for Windows and also some commercial Unixes, because banks like that stuff and they have money to buy software. But one of the things we've always maintained is that the command line tools should be the powerful part. And one of the earlier talks mentioned building machines in Windows and clicking through GUIs and like the documentation required to do that. And as we started working with Windows infrastructure clients, that was something we saw as well. You don't necessarily want to watch someone click through page after page after page of GUI clicks and making sure they check the right boxes. And this revision of Windows changed where that option is, so now all the documentation has to be re-screenshot and all this crazy business is going on. So we have always pushed for comprehensive command line tools so that I can integrate this with other tools, I can integrate it with my Jenkins server, I can integrate it with clouds, all those kinds of things. So we were part of this whole realm where expectations were changing. I'm a sysadmin by training. I did large-scale systems administration for a long time. And you get into the sort of nitty-gritty of what it means to run a few thousand machines, and it's like, well, yeah, I got to worry about this disk that's failing, and I got to worry about the Kerberos thing not being right on that set of hosts, and like that pod over there can't talk to this database over here, so I have to figure out the networking and all this minutia. And while those things are still important, what we found was, it's nice to look at the bigger picture and figure out, like, the job that I'm doing day to day, how are my hands on my keyboard affecting the outcomes for the company? And getting to the point where I can focus on the completion of the tasks that are important and not so much always the things that are super cool for me. So we're looking always towards the value for users, that like shaving 15 seconds off of how fast luggage gets back to you at the luggage carrier or things like that. So we also are working with these expectations of scale, right? So these workflows end up being driven towards more and more and more hosts. And the customers I mentioned earlier, you recognize some of them that have incredibly large infrastructures. And there's just a limit to what physics can give you for dealing with those over a network. But we've seen all of this sort of move. We started out, a lot of folks were still using bare metal. There's still a lot of folks out there doing that, but far fewer than there were. And then moving to full-scale virtual machines, moving all of that into the cloud, looking at containers to see how that goes, and whatever comes next. And it's the whatever comes next that's sort of driving sort of the things that we're thinking about next. But the requirements for speed, efficiency, have not decreased, right? They've only gotten larger. We only want to push more code. We want to put things in front of customers as faster and faster as we can. And we helped a lot of folks respond to dev teams wanting self-service. So that was one of the earlier drivers for DevOps at all, was operations teams taking, as we heard earlier, several weeks to provision hosts for new projects, and you want to limit that time to market for all of your great new ideas. And also, we want to mitigate risks associated with repetitive tasks. Humans get bored, right? Like, I get bored doing the same thing over and over, so maybe I'll script it. Oh, and then I need to debug this script thing, and it's like, oh, well, the machines that it worked on already, then it's not going to do it again, right? So I have to put a bunch of checks in, and there's all this other rigmarole. And a couple of years ago, there was one of the cartoons was like how long it takes to automate something versus how long it takes to do it yourself, and the limited returns that come out from that. So we want to encode as much of the API stuff, as much of the work as we can into this automation so that humans don't have to forget or don't have to remember how all things work all the time, because there's a lot of things that we're doing. Like you saw the Docker stack earlier with 12 instances on there. There's a lot of knowledge that you need in that to know exactly how all those things fit together. But if someone hands you the components in some kind of declarative context, you can say, here's the 12 things that I need. I'm just going to run it, and it should be fine. So working towards those kinds of goals. We want to make sure that those tasks are performed the same way over and over and over again, as often as we need them. I don't necessarily know today if my site is going to be more popular next week, and I'm going to need more capacity at that time. So we've gone into what we called infrastructure as code, and this was as much a marketing term as it was actual reality. It was kind of a way to relate folks to what we were actually driving towards. And when we say infrastructure as code, we actually mean I'm going to put this in a text file, and then I'm going to manage it through GitHub, and I can allow my team to do pull requests to make changes, and all of the sort of workflows that come in with that. And we can also then push it through a Jenkins build or whatever your build server of choice is to make sure it comes out correctly, do a test run of it, do a test instantiation, make sure everything is okay, and treat it as we would any other code. So when we think about the process of getting our application code into production, we can follow a similar process for getting new infrastructure changes into production, which is super handy if you're making changes to your web server and maybe putting new application directories on board, or you're deploying a new web app to your Tomcat containers or whatever you might be doing with that thing. So the way it ends up looking is we tried to make it as intuitive as possible. It's in Ruby, which is kind of scary enough already, right? And so the actual components that you're working with, we tried to make them as relatable as possible. So when I'm talking about installing a piece of software, particularly on Linux, we refer to them as a package. So the component that I'm going to manage in my Chef code is also called a package. And I can do a bunch of fun things with it. I can limit its version. I can actually uninstall stuff if it's not supposed to be there, those kinds of things. But as I make changes to this code, check it into my GitHub repository and continue to run it. Things like users, same sort of thing. I have my user, and we try to follow the pattern of the actual item on the system as much as possible. So I have my UID, my GID, my home directory, and all those kinds of things. So it relates back as much to the system as possible so that when my dev team or someone who's not particularly familiar with the ins and outs of maybe the user add command on Linux needs to make a change, is as apparent as possible how that needs to go. So we collect all of these resources into Cookbooks, and these create these comprehensive rule sets for pieces of software. Usually the cookbook is one kind of server or one set of software components. You've got like maybe a MySQL server and a MySQL client cookbook. There's Tomcat, there's MongoDB, there's a bunch of other things that have these standalone cookbooks that you can make use of. You can consume them from our community. Folks often build their own if there's specific requirements that they have, or we've got hundreds of them that were created by the community and shared over the past 10 years, because we're not necessarily the smartest people in the room when it comes to running MongoDB. We don't really use it, but we've got a lot of folks in the Mongo community who help us out with that. And then we've been working on a lot of integrations, starting out early days with things like VMware, where VMware is a pretty complex product, and it keeps getting more and more, I feel like it gets a lot more complex as you get more into the things that it can do for you. And you want to make sure, just with anything else, that you're deploying things the same way. We also integrate with cloud providers. Trying to make sure you get the same thing every time you click into that AWS console is kind of crazy. Like, I looked at it this morning, and it feels like there's like 10 more things than there were the last time I looked at it. So always having some way of defining and managing these systems over and over again. So you can build these workflows with your continuous integration delivery servers, things like Jenkins. We work with Travis for our own builds, so familiar with those kinds of things there. And then we also integrate with tools like Terraform and other stuff along that line. So you can create pretty comprehensive workflows around what Chef is doing for you, which is provisioning and managing the infrastructure and then layering all your applications. One thing that our community sort of kicked back to us a few years ago was testing. They're basically like, hey, you know what? If you're going to call this infrastructure as code, you should freaking test it as if it was actually code. And once you get a couple of Ruby programmers in the room, they're like, we got to spec all of this. So they ended up building us a couple of tools, one called ChefSpec, which allows you to specifically test all the Chef resources. But we also integrate with things like Rubicop and a couple of other Ruby tools to sort of get that best feeling, right? So that sort of software development lifecycle where you can do linting and you can do like local testing. And one of the other cool ones we have is called Test Kitchen. Is everybody familiar with Test Kitchen? Awesome, right? So Test Kitchen is a local tool on your workstation that allows you to manage local VMs through VirtualBox, I think is the easiest one to put together, but allows you to pull the boxes down and you can test with them locally before you even check your code into GitHub. So I can make sure that I've got my web server, whatever it is, set up correctly, it listens on the right port, and I can give that Chef code now to my dev teams and whoever, and it's all right, and I've tested it locally on my machine before it goes out. So it's super cool. But it gives us this advantage, right? You can test the intent of the infrastructure code, and we can build this workflow that now has these approvals sort of built into it, where I can prove that my intention of putting together an Apache server that runs on 8080 comes out the other end, and it runs on port 8080. So it gives us this solid foundation for the platform, no matter where it's intended to run, whether I'm going to start and put it in the cloud or I'm going to put it in VMware or wherever it's going to end up living. But it also gives teams a place to test for regressions and for major upgrades, right? So like thinking back to when I was a sysadmin like a million years ago, upgrading from versions of, at that time it was Red Hat Advanced Server, right? So there was like a bunch of major changes between a couple of versions and like months of work regressing all the applications that we had to work with. But putting a tool in front of it to say, here's what I'm expecting out of my infrastructure, and that should not change after I update my operating system version, gives me a place to start being a lot more confident in what I'm building. So one of the things that sort of built out of that was a tool called InSpec. And InSpec is very familiar with ServerSpec. So yeah, it's only a couple. So ServerSpec was another project, was launched a few years ago. I think got the young kid who's Japanese, I think. And InSpec is along the same vein, but has a couple different goals. And one of the things that it strives to do is bring together the requirements for folks who are not the most technical hands-on keyboard kind of folks, but have a lot of knowledge about your compliance requirements and things like that. And what we saw as we were working with more and more larger companies was, yeah, they're okay eventually with this automation thing, and they're kind of getting there with the testing part of it, but then when it comes time to actually launch something, they still have a security review, and those folks are like, wait a minute, what did you do? And they have a PDF file, maybe it's in a binder, it's 4 inches of paper of things that they're checking for the configurations of a single Linux server, and those folks work towards checklists, right? You go through your audit a couple times a year and they check things off. And then you have, maybe there's another security team that's maybe separate, and these are the folks that are constantly watching for new CVEs. They're always looking for things that have changed in the upstream providers. They're like, hey, fire drill on Monday, we have to update all these packages for this vulnerability, and those kinds of things. So they're deeper technical people, but still not day-to-day managing all of the systems, and then you have the folks that are actually doing that management. And what we wanted in InSpec is a tool that helps all of these folks sort of get the same work done so it can be done faster. So we can move some of these security requirements, security and compliance requirements, as we say, to the left, right, towards the beginning of the workflow, so that you don't get to release and they're like, sorry, man, you can't use that version of that software, it has a vulnerability in it. And then you have to start back over. So InSpec is another thing. We strive for human readability because, like I said, we have lots of people who we want to be able to consume it, right, to take a look at it. Teams can encode all their requirements, build big profiles, run their tests. They can run it on a regular basis because it's a far lower cost than some of the commercial, larger compliance software packages. Hope to prevent large audits from becoming overly burdensome, because the more often you can check these things, the less big pile you're going to get at the end of 6 months. So you can get then sort of this regular insight into the overall health of your security and compliance requirements. So it's another thing where you can actually build it into your early part of your workflow before it gets into GitHub, before it gets into the dev and QA instances and becomes a problem. In addition to that, InSpec 2.0 launched a couple months ago now, and they put in checks for cloud infrastructure. So as we've been working with large organizations and they're moving to the cloud, the security folks were like, okay, we want to limit what AMIs you can use. We want to limit what networks you can use. We need to limit all of these other things. They basically want to take their on-prem requirements and port them into the cloud. And that's mayhem, but with InSpec, you can start to build some controls around that and say, all right, well, you're allowed to launch these machines, audit this part of your cloud instances, make sure they're all on these particular images, they all have these setups, and meet all of our needs. So it becomes a much more comprehensive thing, no matter where you're actually deploying. So it allows you to sort of combine what we saw with the infrastructure as code and this testing for the infrastructure components, where earlier we talked about installing a package, and it was called package. And if I want to test it, if I want to see what its status currently is, it's still a package. So the language here is similar to spec, which is part of the Ruby testing community or ecosystem, I guess you could say. And looking for things like, okay, I have this package. I know it's supposed to be there. It has to be installed. I want a specific version. So I want to fail if it's not this version. Maybe I know this version has some security fixes in it or something like that. So I want to always require this one. Things like, then for like my user, making sure they have the right shell in case there's a requirement for that. And then you can build up huge compliance profiles on all the things you feel like you need to test on any of your systems. So we can organize them by, these profiles, we can organize them by frameworks. We've built huge ones around things like the CIS standard. So there's a lot of published governmental bodies, NGOs, that write these things. And we've started to collect them all up and put them into profiles. So if you follow a particular standard, and a lot of folks do because it's easy just to say we follow this and then customize it a little bit for the things that don't work. Or you can build rules to fit your particular application. This is our specific set of requirements for Tomcat or whatever it happens to be. Each profile can be created with lots of test files in it, so you can talk about the ports or the services or the user accounts it should be running under, or how often the logs should roll, or any of those kinds of things. And you can pick and choose out of all the components that are available, things that you need, the things that are important to you. Because if you follow some of these standards to the letter, it's like turn off SSH. You might as well turn off the network, right? Like to be fully compliant with some of these, and that's not going to be providing value for you. So it's easy to sort of opt out of particular pieces. And there's a whole bunch of these that our team in Berlin has posted at dev-sec.io. They're the folks that initiated the InSpec project, and they keep up with the profiles and things as they get updated. So this allows us to sort of detect and correct, right? And we can push out our tests, figure out what's going on, and then fix them with Chef. Even though Chef was sort of the first product, that was the first problem we saw that needed solving, that we need to be able to build a bunch of infrastructure super, super fast. But we also see a lot of value in folks starting with InSpec as a starting point to help them set their priorities. If you sort of run a generic profile against your infrastructure and you've got like 200 things that ping red, you have places you know you need to fix. So we can use our InSpec to detect the security issues and then build our Chef recipes to correct them. And we run both of those tools on a regular basis. InSpec is an interesting tool where you can run it on the hosts themselves, or you can run it locally, remotely from sort of your local workstation. So you can actually use a sort of hub and spoke format for it. And it does run against Linux over SSH and Windows over WinRM. So you can test those machines as well. So the way they fit together, something like my Chef resource for package, there's the version that I know I want to have installed, and then there's the verification of it, that my intent was install this package with this version. If you want to go really whole hog and do test-driven development, it's totally possible to do with these particular tools. Build the InSpec tests first, run them, show that they fail, then build the Chef components, converge those, and it fixes everything that was wrong, then run the InSpec tests again to prove that they don't fail anymore. So all that's pretty handy, right? We've got this powerful combination of infrastructure and security automation, sort of goes together piece by piece. And it covers a lot of the time-consuming tasks that we have, right? Like making sure the right package is installed, making sure users are configured correctly, making sure the services that we need are running and the services we don't want running are turned off, because why is NFS even still there most of the time? Or cups. And what we're moving towards, right, is focusing less on infrastructure and more on what's actually going to run on it. And that's sort of our next life, maybe? I don't know. Our next component that we're thinking about is how to think about applications in a way that has the same goals, where we want it repeatable, and we want it flexible, and we want it scalable in a way that is easy to manage, manipulate, automate, in a workflow. And some of this came out of what we saw working with more and more companies is if they're not all one big monoculture, like all their systems aren't running the exact same version and the exact same update of the exact same Linux, because everybody has that, right? You end up with a lot of logic that gets pushed into your infrastructure code and in your testing code for how you figure out where things are supposed to be and how things are supposed to go. And this is just some stuff I pulled out of one of our cookbooks. It's trying to figure out which version of an operating system you're actually on. And if you're on FreeBSD, just abandon it. We have no idea what's going on there. And then a bunch of other Linux versions, it might be true. And if it's SUSE, all bets are off. Like, there's all kinds of crazy business you need to do with different versions. And the more we work with different customers who have different requirements, the crazier these things get. And they're everywhere. So backing up a little bit and figuring out what's the important part of actually working with an application code, and how all those things fit together. And a couple of years ago, we released an open source project called Habitat. And Habitat is trying to capture all these essential components of your application. And it puts them into a single self-executable artifact. So it's kind of like somewhere between a system package and a container. And it includes all of my application's dependencies in a platform agnostic way. So I can take these Habitat things and I can run them on CentOS, or I can run them on Debian, and it doesn't care. And I can port them around and put them in AWS, or I can put them in Azure, or I can put them in GCE, and it doesn't care. And it has a bunch of other components in it that helps you manage these particular things the way they get built. So this stuff is absolutely crazy town compared to where we were coming from. The chef stuff, even the InSpec stuff, builds off of years and years and years of sysadmin work and a lot of other things that we had been doing. And then the team that built Habitat was like, let's just ignore all of that and what comes next. So Habitat's meant to help you not care about all the things that Chef had cared about for the first part of its life. So you take your application code out of GitHub or wherever it lives and wrap it up into its own little package, a Habitat artifact, and put it wherever it needs to go. If you're running on Docker containers, you can export it to Docker. If you are running it just in the cloud, you can run it as its own service on those systems, doesn't matter. And then additionally, if you have a lot of them, they have their own supervisor, and they can chat to each other, and they can do leader-follower, and they can do automatic updates, and all these other crazy things that are built right into the Habitat package. So it's really a new view of applications for us, for looking at what are the essential parts of getting code into production as fast as possible, and worrying less about what's in the infrastructure and more about what goes into the package. So we build our apps in a Cleanroom. So maybe some of us have a bit of nightmares about the QA boxes or the dev boxes having that one sneaky package that was installed by hand, and then when you get to production, it's like, you didn't tell me that you wanted that package, that library installed in production, so I didn't know. So you prevent all of that by building in a BusyBox Cleanroom so that you have no sort of sneaky, undocumented dependencies that just happen to be there. And we create this artifact that we can truly run anywhere. It basically starts above glibc and everything above that you need, and manage it with a native supervisor. So then, in addition to that, last year we launched a build service for these things. So this is a SaaS platform that basically can attach a GitHub repository, and then as you make changes in GitHub, it builds the artifact for you automatically, so you don't have to worry about what it actually means to constantly build and publish these things. So you check in a change, build the artifact, and it can update the running environment to pull things down directly. Or you can actually then export it to Docker Hub, if that's how you're running your services. So let me see if I can, I'll just show you quickly some of the things we can do here. Oh, Firefox wants to install updates. Okay. Oh, needs to sign in. Okay. So I have a small Rust application that has the longest name ever. You see, I forked it from one of my coworkers, if I don't know any Rust. And what I have is, this thing is hooked up to be able to build into what I want, this Habitat artifacts. I want to be able to take this little Rust application and run it wherever I need it, whether it is on my laptop, in a test kitchen instance, or in the cloud, when I have those things set up wherever it needs to be. And the main component for getting something into Habitat is called the plan. And the plan is kind of like, it's kind of like a makefile plus an installer thing and a bunch of package metadata sort of all wrapped up together. So it's a little bit weird, right? It feels like a lot of weird stuff got in there. But if you've ever dug down into RPMs, especially ones that have a lot of patches in them, it's maybe not even quite as weird as that. So things like the package name, the origin, which is my organization on the builder server, and a bunch of other things that are sort of obvious, like the version number and what kind of dependencies it has and those sorts of things. And then it basically tells it how to put it together with an installer. And there's a couple different steps it can go through there. But once I have this little plan file and I hook it into my builder process, the builder service takes care of all the rest. And it's going to download a bunch of packages and do a lot of things for me. So let's see if I can get one to go here. So I'm going to use Test Kitchen just to build up a machine to play with. And it's going to pull down, well, it's probably already local, a version of CentOS for me to play with. And if you haven't seen Test Kitchen before, it's there on the right-hand side of the screen is the definition for what I'm doing with it. And it allows me to have a couple different drivers, right? So here I'm using Vagrant. And I can give it a provisioner. There's a number of different ones, Chef and its competitors, right? They should not be named. And then I can put in a verifier and the platforms that I want. I can boot more than one machine at a time, those kinds of things. But I'm just going to boot this up so I have somewhere to play. And then I'm going to log in. Okay. Okay, we'll let it install some software. So I'm going to have it install Habitat on this machine, and then we're going to see if it will actually run my container sched backend. So fingers crossed with all of that. So some of the things the Test Kitchen can do for you as you're working on your local machine, you give it the infrastructure definitions that you want, right? So in this case, it's using chef recipes. So if my sysadmins are building recipes for my infrastructure, I can hand these off to the dev team, and the dev team can consume them from their local workstations so that as they're building stuff, they're always building against the correct platforms and the correct versions. It's going to hang up on Ruby. All right, I'll finish up, and we'll see if that goes. So anyway, while that runs, through our contact information, you can find us at chef.io. There's a bunch of white papers on how different organizations have put together these tools to fit with their requirements and things that they need. InSpec lives at inspec.io. There's a bunch of discussion there and their documentation. And that team in particular is definitely a place if you're looking to participate in a new open source project. Their InSpec profiles and things at DevSec.io are a good place to get started with that because they're really human readable, super easy to deal with. And then Habitat lives at habitat.sh, and there's a bunch of walkthroughs and tutorials on all of these about how to work with the tools and work with the command lines that come with them, and that sort of thing. We are at Chef on Twitter. Habitat also has a Habitat account for their announcements. We have a bunch of Slacks, and we have a bunch of tutorials and things online for that. If you're looking for Kitchen, it's at kitchen.ci. So let's see if this is finished up yet. Sadly, no. And I don't think I have a movie of it. I don't. What I would have liked to have been able for you to see, in addition to just setting up the Habitat, is that you can manage these things in a cluster, and let's maximize that over the thing that's running in the background. And Habitat in particular has all these tools with it that allow you to manage the updates and config options and things like that. So this particular set of this application are all synced up, and all the application does is print out what its favorite color is. So it's nothing super crazy. But what this allows you to do is, in the context of this cluster, pass it new configurations at runtime. So if you need to change the security settings, or you need to change port connectivity or any of those things while the cluster is running, then you can push that new config in during runtime. It is all self-defined API, so you can put in whatever extensions and things that you might need. In this case, I'm pushing in a new color, and it lets me change the color of the running cluster. So did I have what's in the new config? So it basically lets you upload new configuration via TOML, which is another markup language, and push it through that way. So it's another interesting thing that it allows you to do. So I think, unfortunately, oh, there it went. So real quick, at time, I think. Just to give you a view of what it actually ends up doing. So this is a fresh machine. It just installed the package for Habitat, and it doesn't come with all the things that it needs, so it allows us to constantly update all the dependent packages. If you think about all the potential packages you might need for your application, we build a lot of that stuff and make it available in the builder service. And when I want to instantiate my Rust application, it needs a bunch of that stuff to be pulled down, so it starts to bring it down as I run the application. So we'll let that run. I think maybe we have time for 1 or 2 questions, if there are any, and good to go. Are we done? If there are questions? I will be here the rest of the conference, so if you have any other questions about any of our stuff, find me. If you use our stuff and want some stickers, I have stickers with me, so thanks.